everyone, welcome back to the channel. In today's video, we're going to break down a real-world DataWeave script that covers types, pattern matching, payload normalization, and some powerful string functions. By the end of this video, you'll have a clear understanding of how DataWeave behaves at runtime and how to write clean, defensive transformations in MuleSoft. Before we dive into the script, let's first understand one of the most important utility modules in DWL, core types. When working with real-world APIs and integrations, data isn't always clean or predictable. Fields can change, types can vary, and that's exactly where the types module really shines. It allows you to inspect what type a value is, validate whether it matches an expected type, and safely check whether data can be converted before you transform it. By using these functions, you can write smarter, safer, and more resilient DWL scripts, especially when dealing with dynamic payloads and external systems. With that foundation in place, let's jump in and see these type functions in action. This script brings together several important concepts including type-of, union, and literal types, match expressions, and string utilities, all in a single real-world example. So let's start from the top and walk through it line by line. To begin with, we import the type-of function to perform runtime type inspection within our DWL script. This function helps us identify the runtime type of any value, whether it's a string, number, array, object, or boolean. Finally, we specify the output format as JSON. Now let's look at the variables. The first variable, x, is declared using a union type, which means it can hold either a string or a number. In this case, the value assigned is clearly a string. The second variable, y, uses a literal type. That means y can only ever contain one exact value, the string because. If you try to assign anything else, DWL will throw a type error. This is a great way to enforce strict business rules. Everything after the triple dash is the output body. Whatever we define here becomes the final JSON response. First field demonstrates the type of function on different values. We pass in a string, an array, a number, a boolean, and an object. The output clearly shows how DWL interprets each data type at runtime. This is extremely useful when debugging transformations or handling dynamic payloads. Next is one of the most common DWL patterns you'll see in real projects. We check whether the payload is already an array. If it is, we return it as is. If not, we wrap the payload inside an array. This ensures that downstream logic always works with a consistent array structure, regardless of whether the input contains one record or many. Here we simply output the type of the payload itself. We also show an example object to confirm that DWL correctly identifies it as an object, and these checks are very helpful during API development and troubleshooting. Next section is one of the most powerful parts of the script. We inspect the type of payload, value, and apply different logic based on the result. If the value is a string, we convert it to uppercase. If it's a number, we multiply it by 2. And for any other type, we simply return the value unchanged. This approach is cleaner and more readable than long if-else chains and is ideal when handling multiple data types. Next, we validate an email address using the matches function. This uses a simple regular expression to confirm that the value follows a basic email pattern. The output is either true or false. Here, we clean up a username field. First, we remove any leading or trailing spaces using trim. Then we convert the value to lowercase. This ensures consistent formatting before storing or processing the data. Finally, we process a comma-separated tag string. We split the string by commas and then trim each value using a map. This converts messy input into a clean, usable array of tags. Now let's move on to string functions. To start using them, we import DWL core as strings. This module provides helpful functions such as indexOf, leftPad, rightPad, and replace with real-world examples. The repeat function simply repeats a character multiple times. In this example, we generate 5 asterisks. This can be useful for masking or formatting output. Next, the indexOf function returns the starting position of a substring inside a string. In this example, we search for the word great inside integration. The output is 4 because indexing starts at 0. If the substring does not exist, DWL returns -1. The leftPad function pads characters on the left side of a string until the required length is reached. Here, we pad the value 7 to a length of 3 using the character 5. The result is 557. When no padding character is provided, DWL uses spaces by default. This is extremely common when working with fixed width file formats. In this real-world example, we format a country code coming from the payload. Padding ensures consistent length, which is critical when integrating with legacy systems. The rightPad function works exactly like leftPad, but adds characters on the right side instead. Here, the value ID is padded with underscores to reach a length of 5. Next, we use the replace operator. This replaces all hyphens in a date string with slashes. The syntax is very clean and easy to read compared to traditional function calls. Let's check XML generation in DWL, specifically focusing on namespaces and XSI type, which are critical for SOAP and schema-based integrations. For XML, we need to specify that the output format is application XML. This tells MuleSoft that we are working with XML rather than JSON. Next, we declare a namespace using the NS keyword. Here, acme is the namespace prefix and http://acme.com is the namespace URI. Namespaces help avoid element conflicts and are extremely common in enterprise XML contracts. Now let's look at the most important part of the script. We create a user XML element and attach attributes using the @art symbol. Inside the attribute section, we use the XSI type function. This function adds an XSI type attribute and links it to the Acme namespace. This is a very common requirement when working with SOAP services and XML schemas. Inside the user element, we define two child elements, name and last name. These are automatically converted into nested XML tags. The final XML contains a user element, a namespace declaration, an XSI type attribute, and two child elements. This structure is fully schema compliant and ready for enterprise integrations. In the next lesson, we'll continue building on this and transform even more complex structures. If you're enjoying the series, make sure you like the video, subscribe, and check the playlist for previous days. And share it with someone learning MuleSoft.